Hey, welcome back. So, I recorded all of this without voice, so I'm dubbing over this, so apologies if it's a little bit out of sync. I'm designing a holder for my solder iron and a spool of solder for anything I do in the house, not in the garage. So, here I'm just taking a new component and designing the base, and this particular portion that I'm working on here is the part that's going to hold the spool. So when I was going through this, I thought just take a simple idea with, two sides of the groove and a spindle slides down in the grooves with the spool on the spindle. So here I'm just getting ready to do a cut operation with this new square that I've sketched out, and I'm just kind of tweaking it to get the exact dimensions and the correct spacing for the sidewall thickness that I like. Now, I am by no means a Fusion 360 expert. I do have a decent amount of the basics down, but everybody has something to learn, and I definitely have something to learn. So, by all means, feel free to add a comment down below or hit me up on Twitter or Facebook or whatever with any pointers that you might have. I would greatly appreciate that, because if I improve, we all improve. So, and I think here I was deciding whether or not I wanted some more thickness down towards the bottom of the base that's going to hold the spool. And I'm just checking overall height here. So the other thing I was doing the whole time that I was recording this was physically measuring the dimensions of my solder spool I had on my desk, as well as my soldering iron. So there are a lot of cuts out of the raw video because you got to get up and get a drink every now and then or whatever. So I tried to cut this down to not be very long, to the point where it's boring, and I tried to keep the flow going. So hopefully this is okay and I'm not boring everyone. But so I think right around here I'm moving it, and I make a kind of discovery at the moment in a minute that whole thing that whole component there needs to be rotated, because I wanted the solder iron holder to be to the left of the spool holder, and the way it's sitting right now, there's not enough room to have that. So so here's where I decide that, oh crap, it needs to be rotated. So I'm just moving that, and I didn't go for any particular spacing from the base to the spool holder, the border around it. I just checked the width as it decided to snap in place, and I use that for the next component that I'll be building in a bit for holding the actual iron. So this part here, I'm getting the hole in place for the spindle. So the way I decided to do this was just bore a hole through both sides. So I'm just getting the dimensions correct for the diameter. And I think if I were to do this again, I might change the way I do this, but I'm not sure. I'm not really sure if it could work really any other way for ease of print and everything. I think I definitely would have made the walls thicker on the sides. When I printed it, as you'll see later in the video, they're a little bit thin, but I put pretty big spools of solder on this, So I don't imagine I'll be changing the spools that often, enough to really merit a reprint. So here, just figuring out that it's not centered to my liking. Again, I know there are better ways to do this with constraints. Don't really care. I know how to do them, and I was trying to keep this as fast as possible. And this really isn't a video to show, the right way, the correct way to learn how to do this. But it's just showing my design process. If you do learn something from it, great. But by all means, I'm sure there are better videos to watch. So this part, I'm just trying to find the center of that hole. And I'm just going to take it straight up and ensure 90 degrees. And I'm going to do that on the same, on the other side. Yeah, so Fusion 360 has this thing where if you put your mouse over a particular point and then you move over, say, to the opposite side, it kind of has this like snapping effect that you can kind of see that blue line there. I really like that, but I find it kind of finicky. It doesn't always seem to work. So again, using constraints here would be the more appropriate way, in my opinion. So then I just take this shape and do a cut operation through both sides. And I thought this was a pretty effective way of doing it. So for the most part, the spool holder's done. The grooves are cut in now for this spindle. So I'm just kind of rotating it and getting a feel for it. This was mostly freestyle. The backstory to this is where I work, there was a spool holder made out of metal, and it didn't really do anything out there. No iron holder, nothing really fancy. It just holds the spool. And I thought, that'd be really nice, because at home, when I'm working in my office in my house, not in the garage, I just leave the spool on the table, and it kind of just moves all over the place, and it's not very convenient, and it does end up adding, maybe a couple of minutes to any of the soldering that I do. So that was the inspiration, and I pretty much copied it wholesale for the spool holding portion of this design. I'm not 100% sure what I was doing right there. Sometimes you get lost when you're making this stuff, and especially when you don't really have a design that you're working from. You kind of get lost in the details and fiddling around, which I definitely tend to do. So this is going to be the base component for what holds the iron. And again, this part I just completely freestyled. I just knew that I wanted to have a groove to hold the cold portion of the iron, obviously. And I wanted it to be somewhat universal. I imagine as time goes on, I'll get, a different soldering iron or whatever. Or when I share this up on Thingiverse, maybe somebody's got a different designed one, obviously. So I wanted it to make it useful for not just one type of iron. So I, again, was measuring my iron, and I just kind of padded the thickness, the width of the handle when I made my design in here. And so there I just stole the offsets from the spool holder base and transferred that to this iron holder base. So it had a nice consistent border from the very bottom plate all the way around. And so here I'm just giving a nice incline so that when the tool rests on it, it kind of, helps hold it in place. If I had to do this part over again, the wire on my holder, my iron, makes it a little not so sturdy, I guess. When you put the iron in there, it kind of moves around a little bit, but so I'd probably adjust that at some point. So here I'm just creating a new plane, and I just approximate the angle of the plane to try to go perpendicular to the top of that new base. And once I get that, that's going to allow me to put a cylinder in place on that plane and follow the same angle as the top of that iron holder base component. And I'm going to use that to cut a groove into this for the padded to the size of the iron handle that I have, plus a little bit extra for anybody else that might want to use this. I'm just adjusting the camera angle here so I can see. So for eyeballing that, I think I did a pretty good job at getting that plane angle just right. And here, I thought a lot about how I wanted to cut the rest of that off. I could have done what I did for the spool holder for the spindles on the sidewalls there to cut in, but I decided to just use the tools that were available in Fusion to get rid of those. And right about here I decided that instead of just doing chamfer, I was going to do a fillet to give it a real nice smooth surface. So I decided that's what I liked. Went ahead and did it on the other side. Yeah, so I think that looks pretty good. Of course, there are, a million ways to do this. And again, I was trying to make it more universal for different irons or even different tools, I guess. You don't have to put an iron in there, and you don't have to put a solder spool in the other end. Maybe it's yarn and scissors or something if you sew or knit or who knows what. And so here I'm just picking each edge, and decided that I wanted to make those rounded off. So I do another fillet on these. I really like the looks of the fillet on any of the corners, so I end up doing that for the inside corners. And I don't know about you, but I think that's looking pretty nice. So, yep, they're deciding that I need to fillet those corners as well. Maybe I got a little carried away, but I think it looks nice. So when you have these tight tolerances, like those back two corners, I'm finding that the printers on your shells on a rounded corner like that, I find that you got to add a couple more shells. So instead of like 2, you do 4. Otherwise, sometimes the corners just don't come out real well. Now, I haven't printed these kinds of corners since I've done my fan upgrades from my previous videos. You can see those where I added the 2 new fan shrouds. So maybe I could get away with 2 shells, but I've already decided at this point that I'm going to do 4 shells because I think that'll look really nice and make it really sturdy and not flex a whole lot. Of course, I'm going to print the base at 100% infill for sure. And so here I'm adding the 3D layers brand on here just because I thought it would be fun, and yeah, adjusting it here for 90 degrees. Let me know if there's a better way to set the text in the direction you want by default. I really don't know. It's not a big deal to rotate it, I guess, but I'm curious if there's a better way. And I just don't have a lot of time to devote to learning 360. I pretty much just learn what I need to as I go. So, yeah, here I'm just moving it around. And again, yeah, I could use constraints and really nail down the offsets from the bottom of the Y and to the right of the letter Z, but it's not meant to be exact. Yeah. So here I decided that I'm going to let it cut in about half the thickness of the base. I find that print times and print quality is much better when you do lettering like this versus having it stick up. I can't think of the term right now. Relief, I think, is what I'm doing. Emboss, maybe that's when the letters are above. I don't know. But at this point, it's pretty much done. And I'm finalizing any measurements, just making sure that the bottom of the solder spool is not going to touch the base of that component that holds the spool, because I don't really want it dragging, on the base. And spend a little bit of time getting a component that is comprised of all the other components, and that's really important for when you want to save this as an STL. You can fix it in slicers, but I like to make sure that all this surfaces are properly put together as one. Sorry for all my sniffles and the hoarseness in my voice. I hope that I come through okay. I've had a cold for almost a week now. It's not fun. Oh yeah, I think this is right around the time where I remembered that I needed to make the actual spindle that fits in these grooves. So I'm just taking some measurements and sticking them in Notepad so I don't have to keep using the measure tool. Sometimes I find it's a kind of a pain. I have to keep switching back to various components and remeasuring. So I'll either write them down on a piece of paper or just use Notepad. And I recommend, if you do something like what I'm doing in this design, that you pad your measurements. So the spindle that I make, where it has that notch or groove, if you will, to fit into this slot, I do pad it a little bit, because by the time things are sliced and converted to G code and sent to the printer, and then all the various physical imperfections of the 3D printer and the mechanisms and temperatures and all that stuff, you gotta pad a little bit, because even as good as I feel the Robo is with all the settings tweaking I've done, especially after the cooling, the measurements are still, the dimensional accuracy is still off. And there's only so much you can do. I mean, you can spend months getting it just perfect, and then you switch filaments and it's starting over from zero again. So I deal in averages mostly when I do my designs. So I cut a lot of it out, but I spent some time trying different techniques to build this spindle with the grooves to fit into the walls. And I'm sure there are much fancier ways to do this where you can, come back and make adjustments as you need, but I didn't really like them. So I went for a simple approach, and I just built cylinders on top of cylinders. And as you'll see later in the video, it came out fantastic when I printed this. But I would be curious to know if there's any other way, better, easier, faster way to do this than what I did, making a cylinder sandwich, Big Mac. But yeah, this works. So, just make sure you build each new cylinder on the stack from the center, and away you go, I suppose. So the length of that cylinder right there is 64 millimeters, which is exactly the distance from the inside walls of both sides of this the spool holder base. And I think if I were to do this over again, I would have done, like, I don't know, 62. I don't really like odd numbers, so I don't think I would do 63. I probably would do 62. So finish up the spool here and just kind of checking it over. I don't really know why, but I decided to move it some. Doesn't really matter. Once you export it as STL, you can do whatever you want with it. So the one thing I will say you want to make sure is when you're stacking those cylinders, you want to make sure they end up as one body, because if you don't, and then you export it as an STL, the slicer may have some problems with generating the G code for the printer, and you might get layer adhesion problems or weird artifacts. So definitely, like in the case of this, I did everything by components, which is the preferred way of making things. You want to make sure the body is just one body and not a bunch. So here I'm in Simplify 3D, and I'm just I've just imported the STL, and I'm using the excellent preview tool to see how it wants to print this by default. And I decided that I didn't want it to do a 10% infill all the way from bottom to top. I wanted this to have a little bit of weight to it anyways, and I don't really like the thin layers or thin bases like this to have infill. What I find is that over time, especially when you're using low infill, that infill on the inside tends to crack and loosen over time. And it doesn't really seem to matter what settings I use. And my infill seems, when it's printing, very solid, so I don't think it's an infill adhesion issue. I think it might just be an artifact of PLA. I'm not really sure though. So Simplify 3D allows you to do multiple processes. And so the first process is just setting up 100% infill for the base. And the second one is 10% infill from right after the height of the base all the way to the end, to the very top, the end of the print. And so now I'm just going through the preview again and ensuring that it is 100% infill for the base and then 10% for the rest. So here you can see it is indeed, 10%. And everything looks really good. And I think I probably could have gotten away with maybe no infill. The sidewalls of the spool holder are going to be solid anyways, regardless of infill setting. But I was a little bit worried about the bottom of the spool holder where it's got that nice base to it. And I'm thinking, if I use no infill, I don't know about how the bridging would have looked for those top solid layers. And so I've saved everything. I saved the G code, and I'm getting Octoprint set up and ready. So the design finished up really nice, I think, and went ahead and printed all this. So I printed both of these at 0.2 layer height. Now, I did notice there's a little bit of almost like crystallizing or something on the tip there. So I think I printed this too hot. I printed this at 210. Which is a different setting for a different filament, and I didn't catch it. So there's a couple of areas that might not be as strong as they should be, but this took 13 and a half hours to print at 80 millimeters per second. So came out real nice. And I did two different processes on using Simplify 3D. So up to the top of this part, I did 100% infill. And then from there on, 10%. And looking at how everything came out really nice. I think I could have gone a little bit less on the infill, but 10% is pretty good. Looks really neat. This translucent green is what I used. Let's see here. Yeah. Really neat stuff. And I only got a small bit of it, but this was only 18 bucks. And I printed a couple of other things for myself, and I still have a decent amount, a little less than half the spool probably. So I'm pretty happy with that. And then I got cool gray as well. Sorry, I'm sick, so clearing my throat a little bit and probably don't sound the best. So this was a very surprising print because I didn't use any support and I was a little concerned about these notches here. It came out really good with no supports at all, and I also printed this at 0.2, so you can definitely see some of the layers, but it printed straight up like that, and it took about an hour. There's a little bit of a what do they call it, elephant's foot or whatever on the bottom as it printed, so I need to work on my settings a little bit, but let's see here. Got my digital calipers. I can measure, see if I can get that in frame for you guys. Let's see. So 3.15 and yeah, 2.9. So definitely lost a little bit. So I need to adjust that. And I can do that in Octopi, which I forgot. I will be having an episode of how to do Raspberry Pi with Octoprint and where you can go to support the project, and all the different features and stuff. So stay tuned for that, because it's a fantastic piece of software and it's hard to believe it's free. Definitely encourage you to support the project. So again, another future episode on that. Anyways, so I'm going to test fit this. A little tight. Ah, there we go. So I could probably sand this groove in a little bit, maybe. Oh, there we go. Yeah, that'd be great. Okay, time to get my solder iron and my solder spool. See how it all looks together. All right. So, for any inside projects, I've just got a Weller needle point, and it has 3 LEDs on it, and they're a lifesaver when you're working on real small stuff. So let's see how that fits on there. Okay, yeah, not bad. It actually holds it up really nice. So, and this design will be on Thingiverse. This groove here is supposed to hold the handle, as you saw. Obviously, not the hot end. That just wouldn't work. And let's get the solder. Oh, perfect. Look at that. It's kind of fun. All right, anyways. Oh, I mean, you can't get any better than that. That is awesome. No resistance. Man, I love 3D printing. That's perfect. And I thought about what's up? I thought about having a little eye that holds this kind of up,
But I didn't know if I would really end up using that a lot, or if it would just annoy me. So we'll see. We'll see if I end up using that or not. Not sure. But that is just so smooth. That's awesome. So there we go. So now when I solder in the office, because I do that, as you can see, I've got loads of tinkering projects with another Raspberry Pi 3 and Arduino. I won't have to worry about burning my desk, and I won't be looking for the solder. So this is fantastic. This is a great print, and first try for both of these pieces. This is just a one try print. So I think I've dialed in my printer settings and all that really well. And at 80 millimeters a second, it's pretty darn fast. I'm really happy with it. So thanks for watching, and stay tuned for more videos. Talk to you soon.